Another example I have here is about the use of reed. Reed, as I have here in the figure, it's a material. It's a vegetable plant. It's a plant that we have in Portugal. It's an infestant plant, so people don't use it for nothing, and it grows everywhere. So it's another example that I can give to you that some waste, some agricultural or vegetable waste can be used for insulation materials. But I believe, and Sandra also told about that, the use of agricultural wastes on other kind of materials, also in 3D printing, can be used with some sustainability profit. So this was the first part of my presentation. The second part, it's about digital construction. In CDRSP, we work on digital construction, mostly on additive manufacturing processes. So our goal is to introduce technology in the industry of construction, and we are working on 3D printing. This was the goal of creating the PrintWeek Lab. This is modelation of the PrintWeek Lab that we have nowadays. In this PrintWeek Lab, we have the goal of printing large pieces, big pieces for construction, for example. And in this PrintWeek Lab, we do tests with metals, we do tests with polymers and composites. In the figure, we can see printing ABS polymer example. Also, we work on composites mainly using wastes. For instance, we searched about the use of cork waste on the printing composites. Cork, it's a green material, but also the processing of the cork, for example, for coating materials, generates wastes that can be not incorporated anywhere, and we can use it on composites, for example. And also, we also test, of course, in cement. This 3D print with cement is becoming more and more in the industry all over the world, but also in Portugal. It's very interested on applying this technology and giving a possible answer to some problems in the construction industry, for example, related with the lack of workman force, of specialized work on this sector. So our motivation on the use of cement or concrete in construction is about what we get from this technology about design flexibility. This is one of the big advantages of this technology, but also no use of formwork. So that means that we can with no use of formwork, we can save money and can save also material. The increase in productivity, because with technology we can make it with more production hours, more attractive jobs. We can see that nowadays the construction industry has a lack of interested people working on it. The construction companies have some challenge in having people interested in working on the construction industry. Mitigate the shortage of skilled labor, and also the reduction of errors and accident rates due to automations. We expect that automation create a more safely environment on the construction side. These are the motivations, and we are working on two big areas of 3D printing equipment. We have robots from one side. We have Cartesian machinery on other side. The Cartesian machinery has the advantage of allows us to print bigger than in the robot system. Both can be applied somehow on site or off site. The advantage of using it off-site is to use it on a more controlled environment, which can give us more control on the production level. If we make it on-site, it's more difficult to guarantee like temperature or the environment around the printing element, which make it difficult. And we work on the 3D printing requirements. Here you have some examples of tests. We first have to test the fresh state of the materials. Sandra Lucas already talked about pumpability, extrudability, and buildability. These are some requirements that we need to get on the fresh state in order to be able to print what we need. Also, of course, we have to control the material in the hardness state, which is different from the properties that we get on concrete in the usual process. So in the other state, after 3D printing, we need to check the interlayer bond strength, the interlayer between each layer. So that can be a weak point, and also the flexural and compression strength, and of course the long-term performance. The long-term performance, it's different from usual construction practice because the material, as I said, it's also different. And so we have to check for resistance, for chloride ingress, carbonatation, water ingress. So these are some of the printing requirements that we look for and that we test. One of the examples of works that we made in the past was a kind of green cement based material for 3D printing. In here we use stone sludge, as I said before. Stone sludge, it's a waste from the stone industry companies, and it's a huge problem because we have huge amounts of wastes going to the landfill. And so with this project we got some mixtures that allows us to conclude that it's possible to use those wastes on 3D printing. Of course, there was a huge challenge on testing the pumpability, the extrudability, and buildability of these materials. Here you can see some results, and as it was said before, it's not straightforward. Having a mix, starting from the beginning, having a mix that is able to be pumped or extrudable, it's not a straightforward work. So some of the tests don't go well, but we found a way for it. In the printing tests, we are using mostly a robotic arm. studying those printing parameters and optimizing the parameters like the velocity of the robot, the rotation of the printing head, and so on. We are optimizing the mixture compositions, and also we work on the printing head development. This printing head that you are seeing on the figure was developed by us. So some examples on 3D printing with cement. This is a bench that we print. This is a first test of a wall on a work that we are doing towards building small house. This was the first test on printing the wall, and this was another example of printing a bench. In this case, well, it was just a demonstrative example, but I can highlight here the quality of the printing. The quality of the printing, it has to be good in order to be acceptable, of course. And in here, so we had a requirement on the process. It's not only about buildability, it's also about buildability with quality, which it's needed as a final product. And this was the result of the printing. Some challenges. I cannot end my presentation without talking about some challenges. We have some challenges, of course, in 3D printing. Some of them were more or less said before. The use of reinforcements is an example. The use of fibers is an easy way. I mean, not so easy, but it's a way. It's a more immediate way of reinforce. However, fibers do not replace the usual reinforcements that we usually use in concrete. The mesh mold technology was proposed by Hack. It's about assembling small parts of reinforcing steel bars in order to get a mesh that then is completed with filling it with concrete. It is a technique, more or less automated technique. However, the concrete it's added manually, so it is not fully automated. Another example is the use of formworks, like you can see here in the figure. We can reinforce concrete using the 3D printing concrete as a formwork. It's not about using the concrete, the printed concrete itself as a structural element. In this case, it works only on the formwork. We in this case are not using 3D printing for the structural part. However, it could be an advantage to get a formwork with a shape, with a certain shape that we have difficulty in doing by the traditional process. Also, directly entrained cable, it's another example to introduce a cable while printing. It has been done for a couple of authors. It's not a complete reinforcement, but it's automated. Okay. The reinforcement welding, it's another hypothesis. This is just an example of an author that printed the reinforcement. The press dressing is another way of doing it. We are focused on the mesh reinforcement. The mesh reinforcement could be an alternative, and we are developing the printing equipment to introduce the mesh reinforcement on the mortar in this case. So and in this case the printing will be fully automated, which is what we look for, to get a fully automated process. Another challenge that I want to tell you about is about the link between the design and the printing process. If we want a fully automated process, we need to do it in a fully automated way. So if we have the drawings from the architectural drawing, then we have to give these drawings to the machinery. And this is being done, of course, with the help of some software, but it's not fully automated. There is some handmade work here when the transition is going from the drawings to the robot, for example. And for example, the infill of the object, like you can see in the figure, the infill of the object, usually it's done manually. I mean, the geometry of the printed objects, it's usually done manually. Our goal is to automate also this step. So how can we go in an automated way from the architectural drawing to the final product, also automating this infill part. So the goal is to generate the infill automatically and getting an optimized infill. So this is some example of code of software that we developed, and still we are working on it, of course. And for now, that's it. Thank you very much for your attention.
Thank you, Florindo, for your interesting also presentation. And I think now we have space. This is the last one. We have space for some questions. I ask to the audience to make questions.
Professor Mitchell has a question, I guess.
Yes. Yeah. No, I was just waving to everybody. Florindo, great lecture. Thank you very much. I want to ask you a question about the first part when you were talking about the geopolymers. I suppose there's two questions that form in my mind. One of which is there sufficient raw material to replace the 4 billion metric tons that's expected to be used in 2030 or so in concrete by using geopolymer cement? And secondly, does the use of geopolymer cement make the recycling of building materials easier? Does it have any contribution to that important link? Because obviously we have a huge amount of materials at the moment that need to be recycled, and if we're going to build new ones, it would be good to build new ones which were more straightforward to recycle.
Yeah, thank you very much for your questions. Yeah, they are good questions. Of course, geopolymer compositions and development are still being a challenge. It's not a complete established technique and material on the industry. We are still working on development of compositions. We don't know about the reintegration of geopolymer at the end cycle. That's a good question, and of course we have to think on reusing the geopolymer sample. And this is well, what I can tell you about your second question. About the first question, the amount of waste that we have, it's huge. I believe that it is not so huge that could replace, for example, the use of cement. And also there is a question of performance, because I showed some numbers that give us some good performance, very good performance, I can say, but also that performance it's very variable depending on the formulations. And so we cannot say that we will get enough waste material in order to replace Portland cement. And I believe that in a more or less close future, we can use geopolymers in some extent, replacing some cement, but also we will need some cement in some amounts, I believe.
Yes. I was thinking that with the geopolymers, whether there's some way of reversing the chemistry. I mean, it's a very similar problem to recycling thermosets, because basically cement's a thermoset system, and if there was a way of, at lower temperature, fragmenting it so it could be reused in the system. Because at the beginning you showed three materials, concrete, steel and wood, and the only one of those materials which can be successfully recycled en masse is steel. Yeah. Because it can be converted back into its elemental form. Yes. And the problem with concrete and wood is that's not possible. Yes. And so it was something that Sandra Lucas touched on when she was talking about there's a real need for alternative materials for construction, because obviously it's a terrible industry. I mean, we all love the buildings we live in and we work in, etc. But it's a terrible industry which has been allowed to develop over hundreds of years in a very poor way. It's not being critical of anybody, but it's critical of all of us because we've tolerated it. Yeah. And at some point we have to say enough is enough. And I was struck by when Sandra was talking. Unfortunately I couldn't listen to all of Sandra's talk because I had another meeting, but that we perhaps have to start from a different point, which is not starting from the building materials we have, but to start again from developing building materials which meet the requirements of having a zero carbon footprint and being completely recyclable. I don't have any suggestions for it. If I did, I would share them with you. But I think if we continue to work building on the past successes, accepting that we're going to have to use a certain amount of cement, we're going to have to use a certain amount of poor practice, then we're not going to meet the goals that the UN and the EU Commission have set ourselves.
Yes, I mean, you are completely right from my opinion, and of course we have to think about on always reusing the material and also using materials which have zero carbon footprint. Completely agree. That's the challenge. That's the challenge. And yes, we have to also start thinking about not only on formulation of geopolymers, but at the end of life, how can you use them? Yeah. Again. Yeah.
Thanks for the answers.
Okay. Thank you very much, Professor. Now we have a question from João Matinho. Please, João.
Hi, good afternoon again. How's it going? First of all, again, congratulations for the amazing presentation and for the organization of this wonderful event about this topic. And I have I would say, a slightly provocative question to Florindo, which is, how do you envision construction using 3D manufacturing, additive manufacturing? So do you envision it off-site or on-site?
Well, I think that the potential of the technique in first place is offsite, because in offsite we can control, and there's a lot of controlling on printing. Well, when we print, we have to control the environment, we have to control temperature where the material, when the material is being placed, for example. And this is the most immediate solution for this. And that could be an advantage, and I think, in my vision, is an advantage that in first place put us on the offsite side. The on-site side has the advantage of not saving some transport issues that we can have in printing large structures. That's and also has the ability of using local materials in a more efficient way, in a more sustainable way. I would say that both has some advantages. What I can say is that we have to see what is the one which fits the best the proposal that we have in hands.
You would say that probably it is a trade-off depending on the project itself, I would imagine.
Yes. I would say yes.
Yeah, okay. Thank you very much.
Yeah.
Thank you, João, for your question, and Florindo. We have more questions, or we could end the session? More questions? Okay. For finishing, I thank to everyone, to those that make the presentations, to those that attend and make so much questions, and for your interest also. And we would like to invite you to the international conference at Sustainable and Digital Building that will take place next year in Marinha Grande, in 27 and 28 of October. We hope that time we will have a conference and to meet you in person in Marinha Grande. That is a very interesting and city. So by the end, I also want to thank to the organization team, and I give the last words to my colleague Florindo to end the session.
Thank you